So remember with dividing fractions that we actually multiply by the reciprocal. So I'm just going to rewrite this as 3 over 2 parentheses x plus 1 times 4 over x. Keep, change, flip is how some of you may have learned it. Then from there, I would distribute the 2 in front of the parentheses. So I'm going to have 3 over 2x plus 2 times 4 over x. When we multiply straight across, we'd get 12 over, and now I have to multiply the 2x plus 2 times the x. So that would be distributive property. 2x squared plus 2x. Notice that every term could be divided by 2, so I can simplify this. I get 6, 1, 1. So my final answer is 6 over x squared plus x. For absolute value equations, we change the equal to 12 to both a positive 12 and a negative 12, and we write 2 equations. So the first one would be x minus 3 equals 12. Next would be x minus 3 equals negative 12, and then we add 3 to both sides. We get x equals 15 and x equals negative 9. And if you check these, they work. Plug it back in and check. For absolute value inequalities, we keep one of them, x minus 3 is greater than 2, and our other one would be x minus 3. You have to change the sign and the sign of the number, so less than negative 2. And then we solve these. Add 3 to both sides. I get x is greater than 5, and x is less than negative 2 plus 3 is 1. Since this started with a greater than symbol, remember greater is how I said it, that's an or. And so this is going to have or in between it. If it was an and, you would have to write a compound inequality. Small number less than x, less than big number. For instance, like 2 is less than x is less than 5 or something like that. Okay, and then when we graph this, since it's greater than and not equal to, they'd be open circles. I'll just put 1 and 5 on here so we can do this quickly. And open circles, and greater than 5 would be going this way, less than 1 would be going that way. It looks like oars on a boat. Okay, to write an equation in slope-intercept form, we're talking about y equals mx plus b, but sometimes we don't start with y equals mx plus b. We start with point-slope form, y minus y1 equals m parentheses x minus x1. So it tells me to write an equation that's parallel to. Well, parallel means that they have the same slope. So I'm taking that, seeing that the slope is 2. So m is 2 and passes through this point. So I have a point and a slope. So my point is x1, y1, 1, negative 1 here. So y minus negative 1, which is really plus 1, equals, slope is 2, parentheses, x minus x1, which was right here, 1. So then I have y plus 1 equals, I'm going to distribute 2x minus 2, and now I'm going to isolate y so that I can get this equation to be y equals mx plus b, 2x minus 3. If I had the same problem but I said perpendicular to, then the slope, instead of being 2, the perpendicular slope would be the opposite sign and flip that fraction over. So 2 is 2 over 1, so if you flip it over, it's 1 over 2. Everything else would be the same. It'd be y plus 1 equals negative 1/2, and x minus 1 would be the same. And so just distribute there and isolate y. So there's a lot with factoring. I mean, it's really a huge chapter in algebra, so it's hard to go back and kind of do everything for you. The biggest thing I can say is to always check for a GCF first. So you want to first check for a GCF. The other things that I can tell you that are important are, if you have 4 terms, you would use factor by grouping. If you have 3 terms and a equals 1, then it's basic factoring. So these are kind of all the options you could have. So the 4 terms, 3 terms where a is 1, 3 terms where a is not equal to 1, then you have to do a times c, split the b, and then you'll have 4 terms and you do factor by grouping. Then there's some special circumstances as well, like perfect square trinomials, but especially difference of 2 squares. Difference of 2 squares is tricky. So I'll do a couple of these, but this is kind of the go-to on how to factor, but I always check first for a GCF. Okay, so I always check first if I have a GCF. So for a GCF, I can take 2 out of both and a D. 2D. There's a couple different ways that you can do that. You can write out all of the terms, like 2D to the third is 2 times D times D times D, or you can just know that you take the number that you can divide them both by, 2, and then you keep the lowest of the variables, D. And then you see what you have left. If I take 2D from the first term right here, 2D cubed, that leaves me with D squared. If I take 2D from 4D, that just leaves me with 2. It's like I'm dividing both of those by 2D. Okay, and you can check by distributive property there. Once I've done that, I don't have 4 terms, I don't have a trinomial, and I don't have difference of 2 squares because this is addition, so it's definitely not difference of 2 squares. Difference would be subtraction. Okay, so first I'm checking for a GCF. There's not something I can divide all of these numbers by. So I'm going to move on. I have 4 terms, so I'm going to factor by grouping. In the first group, I can take out a 2p squared. That leaves me with p minus 6. In the next group, p minus 3. In the next group, I can take out a 5 if I want to, and that would leave me with 3 minus p. These are not twins, but they're close. If you notice, this p is positive and this p is negative, so I'm going to have to change the signs. So that 3 is negative and that 3 is positive. So if I keep all of this, change, I'm really just dividing everything by -1. So I'm pulling out a -1. Now these match, so then I would have 2p squared minus 5 and my twins of p minus 3, positive p, -3. You can FOIL that to make sure. That's how you could figure it out if you got a little bit lost with that negative. Here I have a basic trinomial where a is 1. A is what's in front of the x squared, or in this case k squared. That number is 1 right now. So since a equals 1, this is a basic trinomial. I need 2 numbers that multiply to c that add to b. So 2 numbers that multiply to 5 can only be 1 and 5, but they have to add to -6, so it's -1 and -5. So k, -1, k, -5. I can FOIL to get back to the original. Here's another example, but this time a is not equal to 1. That's where we have to do the AC. It's still a trinomial. There's no GCF. There's 3 terms, no GCF. And so, well, there is a GCF of 1, but that doesn't help me. But I am doing a times c, which is -30. I need 2 things that multiply to -30 that add to -7. That would be 3 and -10. So I'm going to change this to 3y and -10y. Then I just bring down the first term, and I bring down the second term. I mean the last term. And now I have 4 terms. That's what I wanted. So now I can do factor by grouping. So I'm just grouping these numbers, and I'm going to see what I can take out of both of them. From the first group, I can take out a y, and I have left 5y plus 3. In the second group, I can take out a -2, and that leaves me with 5y plus 3. So my final answer is y minus 2, 5y plus 3. The last thing is difference of 2 squares. So if you have x squared minus difference of 2 squares, like x squared minus 25. These are both perfect squares and we're subtracting them. So then we take groups and they're going to have different signs, and you take the square root of both. So x and 5. If you FOIL that, you would get back to x squared minus 25. So anytime you have 2 terms with subtraction in between, you want to double check if it's difference of 2 squares. People tend to forget about this one. The last big thing I'll focus on is solving a quadratic equation. Just remember that if it's not in proper form, you're going to have to do some work to it. So if it doesn't equal 0, you can't use the quadratic formula yet. The first thing you want to do is remind yourself of the quadratic formula, which is -b plus or minus the square root of b squared minus 4ac all over 2a. Start singing again if you can't remember that. Okay, so if I have x squared minus 6x equals -7, Well, this is a trinomial. It's quadratic. It has a degree of 2. But I need to move the -7 over to the left so that it will equal 0. So I'd add 7 to both sides. I get x squared minus 6x plus 7 equals 0. Now this is ready for the quadratic formula. You can make yourself a little chart that a is 1, b is -6, and c is 7. That might help you. And then you start plugging in numbers. So negative b, -6 is +6, plus or minus the square root of b squared, -6 squared. Remember, it would be in parentheses like this, -6 squared, so it's going to get you +36. This number will always be positive. Minus 4 times a times c, all over 2a, 2 times 1. Okay, so 6 plus or minus the square root of 36. Now, this part that I'm going to highlight for you, notice that there is one negative in that, so I know that this is going to be a subtraction sign right here, negative. Oops, let's go back to pencil. Negative. And then that would be 28. So it's like 36 minus 28 all over 2. 6 plus or minus the square root of 36 minus 28, square root of 8. 6 plus or minus the square root of 8 all over 2 now. So I'm going to calculate the square root of 8, which is about 2.83. So I'm going to do 6 plus 2.3, which is 8.83, divided by 2. That gets me 4.4. And then I'm going to do 6 minus 2.83, which is 3.17, divided by 2 is 1.59, approximately, 1.59.